Hey YouTubers, it's Crafty Coder here. I wanted to do another quick update on the 8-channel Automotive PDU. I've built up a final pre-production prototype and I wanted to show it off. That's this guy here. It's all-inclusive board now. 12 volts goes into the box, and then we have some power supplies on board to create all the power rails for the low voltage electronics. And then we have all the output wires going out to all the loads. It's still an 8-channel board, but I've only set up this prototype with 4 channels, mostly to save cost. The transistors are expensive, and on the other prototype I've tested the other half of the board, so I know the whole thing works well. I was just trying to make it easy for me. We have a load here, which is a 2 ohm resistor to show off the new constant current drivers that we've got installed now. We've got 2 light bulbs, one large high current light bulb, one 2 amp or so light bulb, and then again electronic load. So we're using all 4 loads now, and the power supply. So let's take a look. So here's the board as it is. You can see some electronics and a radio on top. Underneath you can see some headers and some copper for your current transfer across the board. Over here you can see the spade connectors that actually take the current off the board onto the loads. We have the electronic load here, 2 light bulbs, a 2 ohm resistor, and the power supply. So I've tried to tidy it up. I got rid of most of the wires that were extra before, and now we just have the business wires, which are the current outs, the current ins, and then some ground wires for everything. So let's take a look here. We got the software here. Zoom in the scotch. Now we'll turn on. You can see we got that guy there. Turn it on, turn it off. You can see how the current moves with the slider. Alright, we'll shut that guy off. Now here's the new guy, constant current. Got it set up in firmware right now. I don't have a iOS user interface for it yet, but I set it up to do 1.6 amps of constant current, and we literally just have a wire with the 12.5 volts coming out of the power supply going into this thing, and a ground wire, and across a 2 ohm resistor that should be just over 6 amps. But as you can see, it's only 1.6, so we are definitely doing some switching. This works well through these low ohm resistors. Also works fine through a light bulb. It oscillates at about 90 hertz. The higher the duty cycle, or the higher the current, the faster it goes, up to about 140 or so. I actually have not tested that, but that's what my math tells me it should be. And so that sounds pretty good to me. It moves on a range of about 80 hertz up to about 140. So that's working quite well. We can shut that off. Not that it is very interesting, because you don't see anything there. We still got the little flashlight bulbs there. And then the programmable load, we can turn that on. As you can see, I've got it set to 5 amps. So we'll come over here to it. We'll turn it up to 3 amps. There we go, 3. And we'll just keep turning it up. We can hang out at 4.6 amps all day, 4.7, a little higher. And it'll stay there quite happily all day, but we take it up to past 5 and it's going to pop right there. So that's pretty much it. All the features I promised in a cute little package. It's sort of hard to show the scale here. Well, I guess you can see it next to the phone. Well, the iPod. Not actually a phone, but you can see the scale there. It's not very big. It's not very tall. It's just over an inch tall. And yeah, so there you go. Alrighty guys, we're pretty close to done now. Talk to you.